The hottest part of the Earth is along the equator because that's the part of the Earth that faces closest to the sun. It bulges out. And as that air heats up, it rises. It expands, becomes less dense, rises up through the cooler air. And so the air is rising there at the equator, forming the clouds. The water falls back to the Earth, not the air. The air continues to rise. It's now dry and it's cool. It's dry because it's dropped all of its moisture. It's cool because it's rising higher and higher. Well, as it cools, what happens to it? As it becomes more cool, if heat causes it to expand, then as it cools, it contracts. And so as the air contracts, it becomes more dense. And so what is it going to do? It's going to fall back to the Earth. And on either side of the equator, you have these convection cells. It's moving up and it's moving to the north and to the south. And when it gets into this area, it begins to fall back to the Earth. And so as the air falls back to the Earth, as it approaches the Earth's surface, it begins to heat up because that's where the heat is. And so as the air is now cool and dry, as it gets close to the Earth, it becomes hot and dry. So by the time the air hits the Earth's surface, it's hot and dry air. And it's like a blow dryer. And so if there's any moisture in this area, what's going to happen? The same thing that happens when you put your blow dryer on your hair. It's going to absorb the moisture. And so it's like God has a big hair dryer there, and he's just blow drying this part of the world. What is this?
Sahara.
That's the Sahara Desert. And this is the Kalahari Desert. They're called low-latitude deserts. Okay, as the air is rising up off the surface, what kind of pressure is that going to produce at the surface? Imagine you're at the surface of the Earth and there's this big vacuum cleaner that's just pulling the air up off of you. Are you going to experience high pressure or low pressure? Are you going to feel heavier or lighter? Gigantic vacuum cleaner. You're going to feel lighter because it's going to be like pulling you up off the surface. That's low pressure. As the air falls back to the surface here, what kind of pressure? Now the air is impinging down on you, so it's going to create a high pressure situation. So if you want to have a picnic, are you looking for low pressure or high pressure?
Low pressure.
Well, low pressure is where we have all the rain. Maybe you like a rain, you like soggy sandwiches, then sure. No. If you're going on a picnic, you want high pressure. High pressure is where the air is descending and drying out everything because you want it dry for a picnic. You don't like to eat soggy sandwiches. What's that? Okay, yeah, if you're going to have an indoor picnic, it really doesn't matter. So you have low pressure cell here and high pressure generally here. And so if this is low pressure and this is high pressure, which direction are the winds at the surface going to move? Are they going to move from low pressure to high pressure or high pressure to low pressure? Things always move from high pressure to low pressure, right? Like let's say that my class is a high pressure class. And let's say there's another professor on campus that's a low pressure class. Which class are you going to move toward? The low pressure. It's just the way things work. Everything moves from high pressure to low pressure. They're going to move from high pressure to low pressure. So you're going to see winds moving along the surface from the high pressure desert areas back to the equator. And that's going to complete the cycle. That movement from high pressure to low pressure along the surface is called advection. And it's what generates winds. So the prevailing wind currents at the surface are from north to south in the northern hemisphere and south to north in the southern hemisphere. So it creates a big convection cell. And so through that process, moisture which was once here is being carried back to the equator to form the clouds and the rain. It's like God's irrigation system. Moisture is taken here and placed here. This is an image of the northern hemisphere on the other side of the earth. This is North America, South America. Do you see the equator? See it? So even in the ocean, you can see the equator. This is Africa with the clouds removed. You can see the Congo along the equator and the Sahara, Kalahari. You can see how well defined that belt is. So what you've just seen is a convection cell, a giant convection cell. It's the most efficient way to move heat. There are three ways to move heat. It's thermodynamics. You probably studied this in physics. There's conduction. Let's imagine we have a pot on the stove. Let's say we're cooking spaghetti. It's in a metal pot on the stove, and I reach out and I grab the handle, and it's a metal handle. There's going to be some heat transfer, isn't there? Your hand's going to burn. What's happening is the heat is moving up through the metal. That's called conduction. It's being moved through a solid object. It's conducted. That's a very slow way to move heat. That's the slowest way to move heat. That's the reason when you first put it on the stove, you can hold the handle all you want, and it takes a while for it to move through the handle, right? Now, if we looked at the pot, instead of touching the handle, let's say we put our hand close to it to see if it's hot. Yeah, that handle's hot. That's not conduction, that's radiation, because the heat is radiating from the solid surface through the air to your hand, which is a more rapid way to move heat, but it also causes the heat to dissipate. That's the reason you want to do that rather than grabbing it. So we've seen conduction and radiation. However, the most rapid way to move heat is convection. If you look into the pot, you can see that your spaghetti is boiling. You see the spaghetti moving up and down. So what's happening, the heat in the bottom of the pot is causing the water to expand. It's less dense. It rises and carries the spaghetti with it. When it gets to the top, it dumps the heat into the air, becomes colder, and sinks back down along the edges. That's conduction, which is the most rapid way, by heating up a mass and moving the mass. This is what we were talking about, the warm air rising, cooling, and dropping back down the earth. Then it's pushed back, you see? Same way here in the south. Those are the convection cells. Because the earth turns, spins, it causes those movement to be deflected to the east in the northern hemisphere and to the west in the southern hemisphere. And that determines the direction of the winds. And so they're not northerly and southerly. That would be if the earth wasn't rotating. It'd be northerly and southerly. Because the earth is rotating, we have westerlies and easterlies.